to the channel. All right, cool. What's up, son? All right, so right now I'm going through resistances, value of ohms. Right now we're at 68 ohms. We're going to see how this runs. Dual drive at 68 ohms. I'll explain the dual drive real quick. All right, so basically it's inverse of what it sounds like. I've got two separate circuits and I combine them in one coil to try and get a boost of some kind. Right now there are 3 volts and about 200 milliamps going into one of those drives. We're gonna let it speed up. And then we're going to turn on the other one and just to show you the difference when you turn the second one on. All right, we're going to turn the second one on now. From the way that I see it, you get double the speed, double the torque when you turn the second one on, because it's coming from the same spot, virtually, from a different circuit. So yeah. This is only 3 volts in. We're drawing about 200 total milliamps on both circuits. This is 68 ohms on both circuits. So one of these little blue devils are in there. Teal, actually. 68 ohms is teal. And that's great. I mean, it's only a 0.5 watt tolerance, but it worked. They work. They're working just fine so far. So this is 68 ohms. Let's get a tack reading. $665.7, 669.5. So it's steadily going up. So here's the question. Do we need more resistance or less at this point? So this is 68 ohms. 3 volts in on the dual drive, so it's 695.2. So it's going up like 2 RPMs every time it reads, which is like every 3 seconds. It's going up very slowly. I don't think that's really a good thing when you're dealing with copper this small, that it goes up slowly. It needs to go up fast. 704 RPMs. 3 volts in. 68 ohms. I'm going to try dropping it to 50 ohms. See what we get then, and then I'll go up. I'll go up to 220 after that. So 715, and so far it's consistently going up. We'll give the next one about this much time. 68 ohms. So we'll go 47 now. All my hundreds are gone, so we're not going to do 100. I've already done 150. 150 is pretty nice. 230 is pretty nice. So we're going to do 220 after this.
Lazy Susan for a pizza oven.
Absolutely, man. That's a great practical use for this.
Yeah.
Why not?
Right. Said possibly a low one to start it and jump to a higher resistance once it gets going.
Yeah, absolutely. You need some resistance to generate the electricity on the other end. So I like that idea. This is 47 ohms. Yeah, that's definitely a good idea. Normally what I would do is I would hook up the potentiometer, but right now I'm just going for solid resistance and how each value interacts. Because I can't read the value on the potentiometer, so I'm not going to hook it up right now. I don't even want to think about guessing what's what. So I'm just going to go through each. Like next we're going to do 220. We're going to see if going up helps out a little bit. Not too much, because then it won't go from the start. And I'm measuring the first 30 seconds basically, or the first minute of performance. Everything after that is all the same to me. $6.25. So I'll give it about 20 more seconds. And you gotta realize that one of these is an SSG and the other one is an SSG with gen mode. So they're different circuits right off the bat. So we're gonna get different readings off of each one. That's about 20 seconds. 661.2, so that's even slower up, pick up than the other one.
Connecting one end of each resistor to each other would let you jump a bit.
Yeah, sounds like it might make things a little hot too. All right, we'll go straight to the 5% tolerance. Bless you. These look like they might be the same. are close. Alright. Since the next, little resistor value is 220, I'm just going to plug the 230s in. This is what I consider to be the sweet spot on this motor. At least the spot where I would start using my potentiometer. And I have two 460s, but I'm looking for the other one. So I only have one right now, basically. But that's doubling up what we have right now. Hey, Tiggs. Yeah, your tail's gonna get you zapped. Little baby. Alright, we gotta go out here, okay? Wow, it's moving pretty good for 230. That's awesome. $6.13 right now, about 30 more seconds. So 230 looks like a good place, actually. Because I know we're going to get some generation out of that. Maybe we up it to 460 if we're going to turn it up. Whew, yeah, that was my landlord, and we're good for the next year.
Yeah. Sorry about the interruption, folks.
Some calls you just have to take. All right, so we're going to turn it up a little bit now. We're going to see how high we can get it so that we can run it on the battery. Battery's 12 volts, so trying to get it up to a 9 volt.
Rick said the best method I found for finding top speed is with the scope across the signal of the transistor B connection and negative.
Thank you. So I'm wondering, we're going to set up a kind of like a step level thing here. This is going to be the primary battery, and then I'm going to get out the charge batteries. We're going to set it up Bedini style with the dual circuit here. It's all going through this coil. Got two circuits. Looks like 230 is going to work. And you can't really read the oscilloscope anyway, or the multimeter. So I'm gonna move it. Like down here, I guess. Man, that really sucks. Have to move the whole table just to get it on there. Alright, so get these down here. So if I hook up the potentiometers, it will be on the other side of this 230 ohms. So this is the charge batteries that I'm hooking up right now.
Make a portal so you can jump through it from Monique.
Thanks, Monique. Where's the other end of that portal gonna be? I'd already be the first one to opt on a mission to Mars, so, you know. Opt in.
Bring it.
And it's not because I have a death wish or anything like that, it's because I got balls. That's why.
Oh.
Close those sleepy little eyeballs. It's like it'd take me a month to explain to some people cojones. All right, let's see here. No, I'm just joking, man. I don't play with high voltage, so I don't really know about it anyway. I mean, the highest voltage that I've gotten on this table is 500 volts. And that's playing with pulse motors. And that's not, you know, it's just AC electricity, not peak to peak. Highest peak to peak I've gotten on the oscilloscope was like 1500 on my sine wave peak to peak. So that, I don't know, that's all right. It's not the best. It's like 750 volts. And then it's got the 750 negative, which makes the combination of the two. Boom, boom. All right, so we got our charge batteries hooked up. Let's disconnect it from the power supplies. All right, I want to make sure we're all hooked up before I continue. All right, we're just hooking up. Oh yeah, that's over here. Let's get this off of here. we go. Let me hook up the multimeter. But see, I don't have enough multimeters to really monitor this thing very well. So let's choose two batteries that we want to monitor. Should they be both on the same side, or one on each side, or one differential on each side? I don't know. We only got limited supplies though. So I'm going to see how much we're spending to start. And then I'll look at how much we're generating after that, okay? Good? And if the suggestion is to buy more multimeters, throw me some money and I will. All right, so this one and the light is turning on now. So I'm gonna up the resistance on this side to 460. Or maybe we should just go up to like 330. All right, let's do that. This thing looks like it's gonna be going way too fast anyway right now. So let's just sort this out. So it's this one. So these two circuits are very commingled. They're very dependent on each other because they're in the same coil. They're using the same, not the same strands, but the same coil. So through proximity, they're very much the same. All right, so that's still, let's go up to 680. We're gonna, well, let's try the 460. We'll do it with the big one. Because I don't like the light being on, so I might have to change the circuit if it's gonna be like that. Just to another SSG, but the other one has gen mode, so it's different. All right, 460 ohms. We're still getting the light at 460. And this is SSG without gen mode. Going up to 680 ohms. 680. Almost there. Oh, it's off. Nice. 680 ohms, it looks like, is where the light turns off anyway. That's awesome. Too powerful though. 680 ohms, and maybe we go up to 680 on the other one now too. Just to keep it, together. Although I do think the value of the other one's going to be different because it's a different circuit. That's awesome. And that's unplugged now. That is. All right, let me just break it down for you real quick. This is a 6 magnet rotor at 120 degrees. So they're doubled up. Axial flux. You got 830 turns of a coil right there. There's one strand at 32 gauge, two strands at 32 gauge, and two strands at 22 gauge. So there's 4 strands altogether. And it's 20 gauge, not 22 gauge. All these 2 circuits and everything that they're genning and it's all together in this coil. All right, so the output are these 2 batteries right here. And the input are the 2 big batteries. All right, so now what I want to do is I want to hook up the multimeter on the little batteries and see what we're doing here. I have no idea currently if this is working. I know one side should be working. I don't know if both sides are working. I have done this before, and it's like even though you separated everything, because they're in the same coil, it's commingled. But let me finish hooking up 1206. That's good. All right, so this battery is at 9 1/4, and this battery is at 985, so 9 1/4. Nice. Time to plug it in. So I think it's the battery here that the problem is. Because this says 25 volts on it now. Huh. What did I change, I wonder? So I don't know, maybe we should use the little batteries to drive this? Oh yeah, there you go, the light's off now. You start one, then do the other, and it works out. But as you can see, this is not normal generation. This one's more normal than the other one is. So 11, 9, 7, 9, 8, 12. Really sporadic though. That's awesome. But I want something a little bit more definitive than what's going on here. These batteries aren't charging properly. But that's the basic idea of the DDSSG the way it is right here. You got your primary battery, you got your charge battery. The way that it's set up here, it goes through a diode, a couple diodes, a resistor, a light, can go through a pot, but you know, that's awesome. 680 ohms. This is 680 ohms per circuit. It's still too fast, like way too fast. Awesome. That's awesome, man. 12 volts in. The way I see it is performing a lot better than it was previously. But I think we still need to put more ohms on it. $1K is the next one. Yes? Yeah. Alright, so 1K. And that's residual, man. That's freaking awesome. So this is the extent of my potentiometers. I have 1K potentiometers. This is 1K resistor. Currently, I'm willing to bet we need to go above 1,000. But we will see. Either these are going to light up or they're going to be good. All right, 1,000 ohms, we're generating 0 amps. So it's either not on, or that's too much resistance, or there's not enough voltage in it now. Should I stop it and then try and start it again? Just to see if it's working or not? All right. Looks like it is on. Wow, that is amazing. That's 1,000 ohms right there. Will it ever get going the way it was with 1,000 ohms on it, though? I wonder. Sounds like it. Sounds like it's going to get going for sure. Thousand ohms. Not enough, I don't think.
I got a package.
I got a package. Could you bring it in?
It's a big one.
It's a big one.
Yeah.
Bring it in. Bring it all the way in, please. Okay. That's me. That's me. Thanks. We'll all open it in a little bit. I think it might be my page, yeah. It's like Grandma sent Paige some more stuff. Oh, that is awesome. That's 1,000 ohms. 800. That's awesome, man. We need to go a little bit higher on the ohms, I think.
Awesome sauce.
Heck yeah. I don't got any feed on here. Is there a feed? Chris, is anybody typing anything?
No.
Okay, I was just asking that. Alright, wow, dude. This thing apparently is going faster now. But I turned it off. That's crazy.
Wow.
That was awesome. Sorry, I got excited. And the reason that I have the black top on here, let me show you what I'm dealing with. Is the doubled up magnets are just chilling there. I mean, they do have N52 to N52 attraction, but you know, when these things get going fast, it'll fly off of there. So what I did is I bonded the 3 magnets together with this. So now they all have to fly off in order for it to fly off. So that makes it that much stronger. Not that that won't happen, but it shouldn't happen. I don't think I got that much inertia going on here. But there's a lot of force. But yeah, man, these things have a way after you hook them up to like drain on the power through the output. That I don't know why it does that, but you saw it just happening now.
Those are some scary magnets. Cubics.
So this is 1,000 ohms. That might be where we are. Because it got going that fast without any amperage whatsoever. This is amps broken down to the thousandth, and it says 0 on the thousandth. So that means no amps. Really awesome, man. That's amazing. 1,000 ohms, and this setup equals 0 amps and motion. But you need current in order to generate, I'm pretty sure. Oh yeah, that's not hooked up anymore. What am I doing? Oh yeah, this isn't on anymore either. So I don't know what I'm talking about. You go from doing things one way the first part of the day and then switching to the second part of the day. All this is going on. I don't know the amp reading on this. And that's why it was still going when I turned the power off, because the power was actually still on. But that's awesome, awesome power. I'm gonna hook it back up to the power supplies and try and charge the big batteries, because these little batteries are not giving us any legit reading right now. Actually, I don't care whether it's giving a legit reading or not. Hopefully we can revitalize the batteries. If the batteries can be revitalized, this will be the process in which to do it, I think.
We go outside. We go outside.
Yeah. Yeah, have a good time. So just for S and G, we're gonna hook up a 1500 ohm resistor. See if that improves this at all. I'm trying to bring the speed down a little bit so that I can run it at 12 volts without it flying off. And have it generate a substantial amount of electricity. So this is 1500. Might be a little on the high side now, but as you can see, it's still running pretty efficiently. The axial flush, and it's got 2 ceramic bearings in there. There we go. All right. So this is 1500 on each circuit. And there is power going through to the small batteries. It's just not charging properly right now because the small batteries are It's amazing, man. 1500 ohms. $840. The only reason I'm stopping it is because it's riding high on the shaft. And as you can see, the shaft is starting to wobble a little bit when it gets going. Now, I don't know what's going to happen this time around, but we're going to put 2,200 ohms in. And we're going to run it from the power supply. So we can start charging up the juice we spent running these experiments. So the output's going to be connected to the big one. Connect. Multimeter to the big one. Look at that mess. That is a phenomenal mess right there. And I'm going to have to pick it up. So, there. Okay. see what this one's at now. 1203, 1204, that's right. 1212, that's right. Alright, we're gonna change to ohms now. I know this sounds really like overkill, but we're at 2200. Alright. This is way above and beyond what my potentiometers can do. And then this over here. And now the green one. Bam, we're back to ground zero, pretty much where we started at. Here, let's turn this on. That's, yes, it's on, people. That's 3 volts. Let's turn it up. So right now, we're drawing 0, as you can see. You can hear it, it's on. That's right where we want to be for like a relay or a 0, like a closed loop situation. This is it. This is 200 or 2,200 ohms. We get functionality and 0 amp draw. Well, we get a little amp draw. We're starting to get a little bit. Almost 100 milliamps on 1 meter. That's good, man. That's the reading we want. Not for charging though. Not for generation, it looks like. Oh, this side, see, this is it, man. This side is stuck where it's at 1212, and that side is genning. Now, I don't know how to change that. I think it's happening because of the way the coil is, for certain. So I think this is too high on ohms, for sure. A little bit too high. And you would think that because I'm using a power supply that both of these would be genning. You know, they would both be genning. They both have their individual power supplies. but that one is going up. It says 1208 now. And this one kind of just stays the same. But that is phenomenal motion for 2,200 ohms of resistance. So this is what I want to ask you guys. Should we do 230 ohms, 460 ohms, 680 ohms, or 1,000 ohms? And I can wait. That's all I really want to know. What's our question for the day, bro?
A question for the day. Have you worked with pulse motors at home? 27 votes, 70% no.
So you want to change that up to the ohms?
Yeah. Gotta say it one more time.
Yep, no problem. Just let me know when you're ready for the integers.
What's the question?
What resistance should we run our dual circuit at?
Okay.
And then 230, 460, 680, or 100, or 1,000.
All right. Boom.
Thank you. So this is 2,200 right now. So we're gonna change it up. Just wanna know where you want me to start.
Waiting on the first vote.
Right, that's okay. Kind of scared everybody away. Thanks for hanging in there, people. I really appreciate you.
We got some hardcore fans.
Thank you. I really appreciate it.
Yes.
So it's the 120 magnet rotor. If I just lift this up, if there's anybody new here, we got, oh, that's a problem.
Ooh.
Yeah, we gotta make sure that that's in there. Got two ceramic bearings in this disc right here, and then you got three stacks of neodymium cubes. So there's two cubes here in each node. Okay, so bam, you get twice the magnetic strength, you get the added weight. You know, there's lots of benefits to doing that.
460 ohms.
460. I guess that's where we're gonna start. Because we're at 2,200 right now, so we're gonna back that off a little bit.
Yeah, race like how about 2,500 or more?
Yeah, we could do that next, for sure, absolutely, man, that's probably right where we need to be too.
You gotta vote for 1,000 and a vote for 460.
So we're at 2 for 460?
No, 2 votes total, 1 each.
Okay. 1,000. And then we've got one SSG circuit and one SSG with gen mode circuit. So maybe they should have different resistances. That's my point. There's that one. But we're starting off at 460 a piece. And we will change it to a different one after this. Because it might need more, it might need less. We're going to test it though. Alright, 460 is hooked up. It's just 3 volts in, we're going to juice it up. Awesome. Barely any amperage being drawn. You got 150 on one and 200 on the other at 460. Let me turn the meter on here. Oh, it's on. Okay, we're at 411. Or I mean 1211, sorry. $12.13. They're both going up. I'm pretty sure they're both going up now. But as you can see, it's pretty consistently gaining in speed. $7.30, $7.45, $7.60, $7.72. That's insanely fast pickup right there. So I would say it definitely needs more ohms. It can't be going that fast. Not that fast. Not like this. It doesn't need to go that fast to generate. It really doesn't. If you do more oscillation than wheel, you can make it go slower, and it'll generate just as well. But I love the speed. So 460. What's the one with the second most? Is it any more votes on there?
Yeah, we got 4 votes, 2 for 460, 1 for 680, 1 for 1,000.
Okay, so we'll just go up to 680 next. Everybody kind of thought that 230 was a little low. And that's awesome. I did too, but
John B says 680.
680, sir, coming up. And then we've got, 1K, 1.5K, 2.2K, up to, 1 mega ohm. So, if you've got other suggestions and ones that are in the poll, please vote and give your suggestion as well. All right, 680. I love it when they sync up, man, the amp draw goes down, like way down. When you got the same amount of voltage going in on both of them, the amp draw goes down.
Thumbs up from John.
Thanks, John. So we got the two SSG circuits going into the one coil here, and then they're both working simultaneously. We're drawing about a total of 300 milliamps on both circuits. It's not an equal draw because this is an SSG and this is SSG with gen mode. So they're a little bit different on the input and output. But they're pretty similar, they're pretty equal. Maybe not equal, I mean this one's drawing 400 milliamps, this one's drawing 100 milliamps. Now it's drawing 200, so I guess, so this is 680. Let's look at our gen. Gen's good.
Which is drawing which? Right.
You mean the batteries or the power supplies? Let me explain it. Okay. Currently, we have an SSG and its output is hooked up to this battery. Its input is hooked up to this power supply. So this, and this are together.
Between gen versus normal SSG.
What's the question again? The primary question?
Which is drawing which?
Which is drawing more? I don't understand the question.
Sorry, please continue.
Sorry.
Sorry.
I mean, I kind of get the question, but if we get it in I'll be able to answer it better.
Oh, he said yes. Oh, I'm not sure what to do. Sorry.
Okay, no, it's fine. It's all right. We'll sort it out. We'll get it straightened out. All right, so that's 680. Do we want to change it up again, or is 680 good?
6 votes for 3 of them for 680, 1 for 1,000.
Okay, does anybody want me to go higher than 1,000, or should I just go to 1,000 next?
Another vote just came in for 460.
We'll go back to 460 after we go up. For sure, just to compare.
Alright, sorry, let me rephrase. Is the gen mode SSC drawing 100 milliamps or 400 milliamps while it's running?
The SSG is drawing 100, and the SSG with gen mode is drawing 400. Alright, so we're looking at 1,000 now. Awesome. So there's going to be a card game at the clubhouse for my where I live at, and I'm planning on making an appearance. Play some Texas Hold'em. Hopefully, be able to break open my card deck that I've been holding on to for 2 years. Maybe something will happen at this game that is important to my life. You know, maybe. Okay, 1,000 ohms. Here we go. That is scary how low the amps go. You really don't need any amps to run this. I mean, it's below 100 on, well, the other one has 200 milliamps max right now. So this is 50, this is 200 with the 1,000 ohm resistor in there. And that's the milliamps.
Yanu says wear some gloves, you can get hurt. Don't hurt your fans.
Yeah. Wear some shoes too. But thank you. I really appreciate the fact that you're concerned. I will put some shoes on immediately. Thousand ohms. And this meter over here, you can barely see it in the shot, but this meter is hooked up to the gen mode, and this meter over here is hooked up to the SSG. I'm getting something on my feet real quick.
But
I don't want to ground any transistors that I don't have to. It's got a nice thick 3/4 inch pad. Maybe a little more, maybe an inch and a half. Out by the heel. It's cool. Alright. So that one's going up slowly but surely. I'm not looking for a really fast generation. I'm looking for like a generation that will keep up with the spending, really. And I guess the only way to really do that is to run the closed loop system and monitor it. I'm just making sure this one's going to gen at all. Or, you know, I could hook up this circuit in its place. I just the switch is stuck. I'm not sure which position it's stuck in, whether it's in gen mode or not. But it is stuck. It won't switch.
10 mics.
Awesome. Awesome. So we like 1,000. 1,000's pretty neat. We're generating at a very slow rate. And see, I would run the closed loop system with the SSG with gen mode currently, because it's the only one visibly generating any electricity.
Thousand views.
Thank you. Thank you all. So this is 1,000 ohms per circuit. (927 RPMs). So I think 1,000 is pretty good. 942. Might want to go 1,500 or hook two resistors together and go like 1,200 and 20 or something like that. All right, I'll be right back. And that's got a great residual spin on it. It's got ceramic bearings. Hold on just a moment. Hi. How you doing? All right. So what was I doing now? Oh yeah, let's swap the circuit and see if it's stuck in gen mode or in the other mode. At least if it's stuck in gen mode, they'll be a lot similar than they are right now.
Rick says try more ohms.
Yep, we're gonna go 1,500 next. But we're gonna swap the circuit. So that's SSG, and now we're putting SSG with gen mode in its place. I hope it's all working properly.
What are you building?
I'm building a dual drive pulse motor. Just kind of trying to add up the circuits now, or just balance everything, balancing right now.
I'll be back in a minute. I gotta use the brush.
All right. All right. That's hooked up. Now, hook up that, and hook up that. Now, you just need to hook up the resistance. Now see, this is an older version of the circuit, and so there's only two positions in the block for you to put resistance. Okay. We are almost completely done here. Yeah, I'm not getting any feedback on my phone for the messaging. So we'll just have to wait if you're giving me any feedback from my rotor return. Okay, let's see now. Oh yeah, we gotta hook up the last plug. It looks like it's switched on its own. That's weird. Looks right though. Let's see. No, I think it's wrong. It's got to be switched the other way. Let's hope and pray. Dude. Do we have another one? I think we have another one. Let's see if that one. Oh yeah, that one switch is completely broken. All right, so we want to turn this into an SSG with gen mode. Huh. So if I make it run through two diodes one way and one diode the other way, so like if I attach a diode clip that has it going both ways out the output, all right, so we'll try it this way. All right, so we got our diode going this way and this way, right? Oh no, it's not. So we gotta flip it. Right? And then we hook it onto this, like so. So we want them all, we want these both to come back onto the same line. So we can either clip them on the same line or we just put this on it. That's either gonna go like this. God, come on, man, give me a break, dog. Give me a break. So hopefully this will change it to a gen mode scenario. Bingo. All right, so we want to put it on this other one here, though. All right. Off of this. And this is just based off of looking at the back of the other SSG the general. Do I know if it'll work? I do not. Wow, man, he really wanted to get in there.
Yes, he did.
So we're looking at to go up from 12 to 13. I don't know if it will. So another way that I'm going to try and run the relay that I've been working on is without the SSG. I'm going to use the MLJs, MLJ 21194Gs. I'm going to use those, and I'm going to use where is it? This thing. I'm going to use these. I'm going to make kind of like my own circuit. Not really. I'm sure all this stuff has been done before, but I'm going to hook it up differently. Use different transistors, different resistances. Heck yeah. But it looks like it's still got the same output. So it looks like my contraption here didn't help. Huh. So let me think. So just in case they are one-way clips and not two-way clips, I'm going to disconnect this part. And we're going to clip one there. And we'll take this off of that and we'll clip the other one to the same place, basically. Thousand ohms though, 1,000 ohms. So I've tried a couple of connections here to get, more amps to come out of this meter, but it's not working. But 1,000 looks like it's working just fine, actually, now. So let me undo all this real quick. It's easier to take apart than it was to put together. Yeah, I think renouncing SSG for a while might give us a little bit more freedom in what we do. And we'll be able to explore a little bit more. Right here, it's pretty simple. You know, you got your input, you got your output, you got your resistance, you got your coil set up, and that's pretty much it. You put your transistor in, and you're limited to about 6 combinations. And I'm not talking about different coils. That opens up a whole nother ball of wax. I'm just talking about what you can set up with 2 of them. There's limits there as to what you can accomplish. But it's a great circuit, man. I use it all the time because it works so well. Mm. Alright, so what I think I'm going to end up doing, since this is stuck in SSG mode, is take the gen mode out and put the SSG mode in, so we're working with 2 of the same circuit. Because this one, it's weird, man. It's just, the switch is stuck. It's just stuck in SSG mode. Alright.
All Effect X, afternoon, Papa Bale.
Hey, what's up, Paul Effect? We're trying to at least sync up our circuits here. Trying to get 2 SSG modes that are running the same way. And trust me, I'm doing the best I can. So, yeah. Alright. So now we're hooking the SSG up. This one's stuck in SSG. The gen mode is working fine, but we only have 1. The switch got stuck. got those hooked up correctly. Oh yeah, I gotta do the resistances still.
You working with 280 ohms?
680. Well, no, it's 1,000 now. Right now I'm running 1,000 ohms, but I'm currently hooking up a circuit here.
1K in the house.
Heck yeah, 1K seems to be right where this system likes it to be. I'll put it just out of my pot's reach. It's not, I'm not hooking up a pot to not just to be turned all the way over to the side. Because my hands are clumsy. I don't have any proper clips to hook them up with. And yeah, man, no. All right, almost done. You gotta respect the differences too. They're not all the same, all the systems out there. They don't all work together very well. Come on, man. Oh my God. All right, we're almost there. Well, we're there. I just need to get this cord out of the mix here. All right. BBD, 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 BBD.
Halifax says I've been frying transistor after another, finding out with Exeter circuit.
Yeah, that's awesome, man. I saw how huge that Tesla coil was, man. That's amazing. So now they're equal to about 250 milliamps coming out of both of them. Finally. But now I think the resistance is wrong. This one's now at 1218. Holy smoke. So now it looks like it needs less resistance, yeah?
He says, thank you, I see the double stack and all the technical work you do. Awesome sauce.
Thank you, sir. A lot of people would argue that magnetic strength doesn't really matter. I say in the first 30 seconds it matters a lot.
All right, man, I got about 10 more minutes. I got a lot. And I want to do the editing too.
Okay. All right. So as a tag team, we're going to be done in about 30 minutes, 10 minutes. I think this is great. I'm going to get pots that I like working with. I like this style, maybe more turns, but this big at least. The little tiny ones, I'm not working with these. These little blue ones right here, I don't like these. Unless I have the proper clips to hook them up with, I won't use them. Nah, that sucks. I have a few more of those, but they're just until I get the proper, connections for it. I'm not going to use it because it's damaged two of my transistors. I hold it personally responsible for damaging two of my transistors.
It's like, cool, then I'm gonna play Jurassic Park.
Hell yeah, man! Jurassic Park is a great game. I played it a little bit in the last couple days because of you. You said I'm playing it, so I decided to check it out. So we are working with SSG Gen mode, or not Gen mode, but SSG straight up. Currently, only one side is charging though. I don't. That's just typical for SSG, you know.
Have you rescued the Triceratops yet?
No. I've only gotten to the Achiosauruses where you had the pen that got destroyed, and you got to rebuild the pen and make it strong enough and make everybody happy, all the dinosaurs happy and everything. So it's like the third mission.
Cool.
Heck yeah.
Most variacs are low resistance meant for 60 hertz. Maybe interesting at high frequencies. Great.
Variac? Yeah, I haven't even busted open my Variac yet. And it's got the dial on it. It's not a digital one.
They're even pricier than rheostats.
Oh yeah, we're past buying one. I've got one already.
Yeah. We got stockpile. And he learns how to use everything he gets eventually.
So it's a 0 to 130 volt output, AC 60 hertz, IMAX 20 amps, voltage regulator. So input 120 volts. So you can plug it in, you get a 10 volt boost if you want. And then you get to play with the voltage in between 0 and 130. I think it'll be awesome. But I think I'm gonna lower the resistance on this now for our next battle. So yeah, if there's a way that I can hook this Variac up, like you were saying before, and lower my bill at home, I'm all for that.
Yeah.
1224. Now this one's charging and that one's not.
I ran the output to a high voltage rectifier for some strong DC.
Oh yeah, so you just hook that output directly to a bridge rectifier?
You need a transformer to hook the Variac to lower the electric bill.
I see. Is it like a Mott transformer or a different type of transformer?
Rick says it would be used in place of a resistor potentiometer. Unusual.
I guess that's kind of good that it's not showing up on the screen here. I don't know.
We like unusual.
Unusual is good. I got an idea. And this might be what the problem is, or ever always was. Or just let me see what happens when I do this. Oh no, that's still working. All right, so from 1,000 ohms, we're gonna go down because apparently, I don't know. I think we're gonna go down though with the ohms. 680. How about we just back it down to 680? No? All right, we're gonna call it for a little bit. And we'll be back later on. I hope everybody decides to swing on through. We're going to be looking at our axial flux with our dual drive coil. We currently have 2 SSGs going into the coil, and we have 2 outputs coming out. We're currently trying to charge 2 batteries with the 1 coil. It's not working too well right now, but we're going to keep trying to do it. We'll flop resistances. Might hook a pot up to the one that's failing. See if we can't make it happen. You know what I'm saying? And then yeah, we'll go from there. And we're gonna try and hook this up closed loop. It runs very well on 2 12-volt batteries. But yeah, that's pretty much it for right now. We were charging 2 batteries with 1 coil. Awesome. Thank you very much. Peace out. Have a wonderful day. Please subscribe, and I'll get back to you later on. Peace.